Hi, I'm playing with it again. That's what she said. Except it wasn't to me. Greetings, the Astro 30 here yet again, and all jokes aside, I'm looking at this simple audio home power amplifier, or was it simple home audio power amplifier, whichever way around it was. Now in the last video on this I did not do a frequency response test, and the only reason I didn't do a frequency response test was because the video was getting quite long and I spent the majority of my time just trying to get the damn circuit to function correctly, because it had a humongous DC offset on its output. And if I remember, I'll put a link in the top here to that video so you can get that for reference if you haven't seen it already, and in the description. Anyhow, so I'm just going to get set up and run a frequency test, or frequency response test on it, because I noticed that when I was going into the speaker that the highs don't sound right, unless I've inadvertently damaged the tweeter when I plugged it in and had that really loud 100 Hz going through it, which was DC mains ripple, because it is only a piezo diaphragm and it could be easily damaged, but it does have a blocking capacitor and a resistor in series with it. It's unlikely, but that's the reason why I'm going to do a frequency response test, just to make sure that we're getting a reasonably flat response between the 20 Hz and 20 kHz range. And I'm going to use, not the laptop this time for that, I'm going to use my little oscillator generator, because that's got a cleaner output. The laptop's not really a good measuring tool. Let me get set up with some test equipment, dummy load and power supply and all that fun stuff, and I'll come back. Alrighty, it always is a pain in the ass to set things up like this, but I've got everything set up. So, function generator, well, the oscillator's just over there on the right. Don't know what frequency it's set to at the moment, but I'll find out. I'm going to plug it in. Everything's hooked up right, as far as I know. That's because the amplitude's too high. I was right up. So I'll stick it down at 600 millivolts roughly, which is 15.5 volt out. That means we're getting around about probably 10 watt out of it. So now I just need to increase the voltage per division so we can see the signal. And we're not quite at 1 kilohertz. So I'm looking through the viewfinder of the camera. Right, so we're at 1 kilohertz thereabouts. So we'll take a baseline of 14.5 volt, and I'm not going to change the amplitude or anything. Alright, I had to stop the camera there for a minute. Without changing the amplitude, we've still got around the 14.5 volt mark thereabouts at 10 Hertz. Well, actually, what are we at? 48 Hertz rather, sorry. So I'll wind it down to 20 Hertz, get some more things on the screen. And it's around about the 14 volt mark, so it does start rolling off a little. And if we go right down to 10 Hertz, it is 12.7 volts, so it does roll off at 20 Hertz, which is fine, I suppose. What's the wrong way? No, I was going the right way. There we go. So 20 Hertz. I need to change my jumper setting in a minute. Wrong way. I always go the wrong way. Apparently that's 200 Hertz or thereabouts. Still 14.5. Okay, so now I'm on the 100 to 3K. I'll wind the course up. It's still remaining reasonably flat. Need to get some more on the screen. The little 14.5 volt mark, we haven't got back to our baseline of 1 kilohertz. There we are. Go up a bit further. We're now at 4 kilohertz. And it is dropping a bit. I need to change my jumper again. So far it is remaining reasonably flat. We're now up to 4 kilohertz, 5 kilohertz, 6 kilohertz, 8 kilohertz. It is starting to roll off. We're at 20 kilohertz and we're now at 11.2 volt peak to peak roughly. So we are rolling off. Now where are we rolling off? That's the question. Back it back down. I'm going to say the 4 kilohertz mark is where it's starting to really roll off. So what is my course of action here to try and improve the frequency response? Well, I could increase the value of the input capacitor, or I could change that 100 microfarad out for a electrolytic, which I don't think is going to make any difference, or I could lower the value of that capacitor because I think it may be too high. But what I'm going to do first is I'm going to change it to an electrolytic and see if that makes a difference. Probably not. Okay, capacitor is changed. I'll just plug it in again. Interesting, we have no output now. Okay, because I've missed the resistor, that's why. I am such a dumbass. Let's try that again. Still no output. What have I done now? I've still managed to miss the resistor. Right. Third time's the charm. There we go, we've got an output. Right. It doesn't appear to have made any difference. Okay. So, I might try my first theory, which is increasing the size of that 10 microfarad capacitor. I mean, it should work with a 10 micro in there, but I'll put a 22 in there instead. Okay, the 22 is in. Okay, got an output. It's still rolling off. Okay, so it's not the input capacitor. Okay, I've changed the 100 microfarad out for a 47, and I changed the input capacitor back to a 10. I don't see the need for a 22 in there. Alright, we have an output. Well, it is rolling off a bit less, but yeah, I really don't think the issue is the choice of capacitors here. But at least the signal is clean. That's the main thing. So in conclusion, I don't know what to really tell you except that the frequency response is reasonable. It does roll off at the low end and high end slightly, but in general it should sound alright into a speaker. There's no reason why it wouldn't. I will preface this though by saying that breadboard, yet again, is not an ideal medium for constructing power amps on because of the stray capacitance and all the connections, and of course all the wires running in various different directions. If my wiring was probably a lot tidier than it is and not having wires cross over like this, like that's a ground wire crossing over a signal wire which is part of the power side, yeah, it's not a great medium or ideal layout. It'll probably perform a lot better on a dedicated PCB or even a piece of strip Veriboard or whatever. Of course, I just don't have the time or the motivation to build it up on Veriboard just to test a theory. I've tested the theory on breadboard. It does work. It works reasonably well for what it is, and I'm just going with that. And just for completeness, here is the revised schematic with all the changes on it. I forgot to show it in the last video. I'm showing it now. So that's the amplifier that I've tested and what I've come up with from the original design. Is it changing the premise of the original design? Yeah, it is, but I don't know if it's for the better or for the worse. But as I said, testing frequency response on a breadboard is not really a good medium, especially for power amplifiers, and RF circuits are 10 times worse on breadboard. There's a lot of stray capacitance, which affects things like oscillators, mixers, and IF stages as well, and it can be awfully difficult to get good results, as well as keeping it from drifting in frequency in the terms of oscillators, for instance. Anyhow, that's beside the point and out of the scope of this video. So I think I've left this on the screen long enough. So I'm going to close this video out. It was only a short one, but I just wanted to know what the frequency response is. It's average. I'm going to go out on a limb and say it's a flat response between 20 and 20 kilohertz, or 20 hertz and 20 kilohertz, I should say. Anyway, if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and become a Patreon supporter for as little as $1 a month. Need more supporters, please, guys. Anyway, links are all in the description as usual. This is the Astro 30 saying, see ya, have a great day, I'll see you in the next one.